Good morning, students. How do you do? Are you enjoying the sessions? Hope so. Today we will take classifications of turbines. How turbines can be classified. Turbines are the hydraulic machines which convert hydraulic energy into mechanical energy. The turbines will convert the hydraulic energy into mechanical energy. Working principle. The working principle is very much simple. When the fluid strikes the blades of the turbine, the blades are displaced, obviously, which produces rotational energy as the blades will rotate when the fluid strikes the blades. The turbine shaft is directly coupled to an electric generator. Generator converts this mechanical energy into electrical energy. This electrical power is known as hydroelectric power. If you see the classification, you can observe here impulse turbine, reaction turbine according to the type of energy at inlet. According to the type of energy at inlet, it is classified as impulse turbine, reaction turbine. According to direction of flow through runner, it can be classified into, just let me zoom this. Okay. According to the direction of flow through runner, tangential flow turbine, radial flow turbine, axial flow turbine, and mixed flow turbine. According to the head at the inlet of the turbine, we can classify turbines as high head turbine, medium head turbine, low head turbine. So whenever we say high head, medium, low, at least values should be attached, or we should know the values of head. That will come in future slides to come. According to the specific speeds of the turbines may be classified as high specific speed turbine, medium specific speed turbine, and low specific speed turbine. Is it clear? There are 4 different bases on which the turbines are classified. According to the type of energy at inlet, impulse turbine, reaction turbine. According to the direction of flow through runner, tangential flow turbine, radial flow turbine, axial flow turbine, or mixed flow turbine. According to the head at the inlet of the turbine, high head turbine, medium head turbine, low head turbine. Whereas based on specific speed of the turbine, it is classified as high specific speed turbine, medium specific speed turbine, and low specific speed turbine. Impulse turbine. Impulse turbine. If at the inlet of turbine the energy available is only kinetic energy, then the turbine is known as impulse turbine. Example is Pelton wheel. So this is the Pelton wheel. On the periphery, buckets are attached. When the stationary nozzle exerts a jet of water onto these buckets, this will move in the anticlockwise direction as shown in figure. Types of impulse turbines. Pelton wheel or Pelton turbine is one of the good example of impulse turbine, and cross flow turbine. Those 2 photographs are here to see how Pelton wheel looks like and cross flow turbine looks like. Pelton wheel or Pelton turbine. This is Pelton wheel or turbine. It was invented by Lester Ella Pelton in the year 1870s. Pelton turbine is suitable for high head and low flow rate. Head should be high, flow rate should be low. Energy available at the inlet of the turbine is only kinetic energy. Pressure at the inlet and outlet is atmospheric. Cross flow turbine. It is developed by Anthony Mitchell in 1903 and is used for low heads, say up to 10 to 70 meters. As with a water wheel, the water is admitted at the turbine's edge. After passing the runner, it leaves on the opposite side. You can see here. It enters and then it leaves in the opposite side as shown in figure. Going through the runner twice provides additional efficiency. Means the jet of water entered at the entrance will move twice the runner while going through the runner twice provides additional efficiency. The cross flow turbine is a low speed machine that is well suited for locations with a low head but high flow. Reaction turbine. If at the inlet of turbine water possesses kinetic energy as well as pressure energy, kinetic energy and as well as pressure energy, the turbine is known as reaction type. In a reaction turbine, forces driving the rotor are achieved by the reaction of an accelerating water flow in the runner while the pressure drops. You can see here the different major parts: impulse turbine, reaction turbine. Impulse turbine looks like this and reaction turbine looks like this. Here the fluid nozzle, moving buckets is shown here also. So many buckets are connected. Fixed nozzle through which the jet of water entering and hitting the buckets. Here it is rotating nozzle, here it is rotating nozzle. Here nozzle is fixed in case of Pelton wheel or impulse turbine, whereas in reaction turbine nozzle is rotating. That is the basic difference between these two. Types of reaction turbines may be Kaplan turbine, Francis turbine and kinetic turbine. Francis turbine. The Francis turbine is a type of water turbine that was developed by James B. Francis and hence the name, are used for medium head 45 to 400 meter and medium discharge 10 to 700 meter cube per second. The Francis turbine is a type of reaction turbine, a category of turbine in which the working fluid comes to the turbine under immense pressure and the energy is extracted by the turbine blades from the working fluid. The turbine's exit tube is shaped to help deaccelerate the water flow and recover the pressure. So in order to recover the pressure, the exit tube is shaped to help deaccelerate the water flow. So this is few schematic sketches of turbines shown. Whenever you find free time, you can watch of Francis turbine different parts. Kaplan turbine. It is a water turbine which has adjustable blades and is used for low heads and high discharges. It was developed in 1913 by an Austrian professor, Victor Kaplan, hence the name Kaplan turbine. The Kaplan turbine having drop height 10 to 700 meter, whereas flow rate very low flow rate for low heads and high discharges. Flow rate is 4 to 55 meter cube per second. Height is 10 to 700 meter. That's why it is said here for low heads 10 meter. Flow rate, high discharges 4 to 55 meter cube per second. These are the various parts of turbine: stator, rotor, turbine generator shaft, this one vertical one, then turbine blades which are provided. These are the blades. These are the blades, and wicket gate, etc. are shown in figure. According to direction of flow through runner, the classification, if water flows along the tangent of the runner, the turbine is known as tangential flow turbine. Along the tangent. If the water flows in radial direction through the runner, the turbine is known as radial flow turbine. If the water flows from outward to inward, then it is known as inward radial flow turbine. If it is from inward to outward, then it is known as outward radial flow turbine. If water flows along the direction parallel to the axis of rotation of runner, the turbine is called as axial flow turbine. If water flows in radial direction but leaves in the direction parallel to the axis of rotation, the turbine is known as mixed flow turbine. If the water flows from outward to inward, the turbine is known as inward radial flow turbine. If the water flows from inward to outward, the turbine is known as outward radial flow turbine. Both are given along with the sketch. According to head available, very high heads. So I pointed out we should know the value. Very high head means 350 meter and above. Example, Pelton Wheel. High heads, turbine 150 to 350 meter, Pelton and/or Francis turbine. Medium heads 60 to 150 meter, Francis turbine. Very low heads below 60 meter, example, Kaplan turbine. According to specific speed, turbine specific speed and remark. Pelton wheel with single jet 8.5 to 30 specific speed up to 43 with double jet. Francis turbine 50 to 340 specific speed, whereas Kaplan turbine having the specific speed of 255 to 860. Summary of classification. According to the type of energy at inlet, impulse turbine Pelton wheel, reaction turbine Francis and Kaplan, which requires low head and high rise of flow, whereas Pelton wheel requires high head and low rate of flow. According to direction of flow, tangential flow turbine is Pelton wheel, whereas Francis turbine is radial flow turbine, Kaplan turbine is an axial flow turbine, whereas modern Francis turbine is mixed flow turbine. According to head at inlet of the turbine, high head turbine is Pelton wheel, medium head turbine is Francis turbine, low head turbine is Kaplan turbine. According to specific speed of the turbine, low specific speed turbine is Pelton wheel, head is high, specific speed is low. Medium specific speed volume turbine Francis turbine, high specific speed turbine is Kaplan turbine. Thank you very much. We will continue in the next class. Okay. Have a nice day.